Today we'll discuss holes in rational functions and when they occur. A hole is simply a point on the graph where the function, as well as its x value, is undefined. When do they happen? Well, when the numerator and denominator of a rational function have a common factor, they will cancel out when simplifying the function. This cancelled value creates a hole in the graph. Now, in order to find the coordinates of where the hole occurs, since we already have the x value, since we got it from the cancelled value, we plug in that same cancelled x value into the updated function, aka the simplified function, in order to retrieve the y value. An important thing to note is that in order to find the other information, such as the vertical asymptote, horizontal asymptote, and zeros, you'll need to use the updated or the simplified function to do so. Let's say we want to find the holes of this following rational function. Well, the first thing we want to do is factor out both the numerator and denominator. And we can see that they both have a common factor of x minus 2. So we can cancel that out. And we can see that the hole is at x equals 2 because when we plug in 2, we can see that the function becomes undefined. So now we can cancel those out from both the numerator and denominator, and we'll have an updated function which we can call g of x is equivalent to x plus 3 over x minus 1. Now note that I am not saying that these two functions are the same. And I didn't say that because one is called f of x and our updated one is called g of x. But an important thing to note is that g of x will be the same as f of x if we state the hole, which we will. Now in order to find the hole, we plug in x equals 2, which is the cancelled x value from f of x. And we plug that in into our new updated simplified function, which we call g of x. And we got g of 2 equals 5. So now we can say that the hole is 2, 5. Now, these following graphs are of f of x and g of x. Now, note that they are pretty much the same graphs, which is the end goal, right? We don't want to change the actual function. But we can see in f of x that there is a hole at 2, 5, whereas in g of x, it's not. Because in f of x, the x minus 2 existed, but in g of x, even though it didn't exist, we still stated that there's a hole in 2, 5. So if you were to draw the graph with the hole at 2, 5 of g of x, you get the same exact graph as f of x, which is our end goal. I hope this video helped. Comment down below any other math topics from your review. Thank you.